Welcome to RR Max. We will continue with reduction formulae episode 5. I'm continuing the problem like the previous problem. This time also we'll take a similar one. Evaluate I is equal to integral 3 to 7 root of x minus 3 into 7 minus x both under the root dx. Now here also we'll use a substitution similar to what we did in the previous problem. So put x is equal to 3, that comes from x minus 3, 3 sine square theta plus 7 from the other term plus 7 cos square theta. So as usual you go with dx. For the first term it is 3 into sine square theta, you differentiate, you get 2 sine theta into differential of sine theta is cos theta, giving you 6 sine theta cos theta. And for this plus 7 into 2 times cos theta into differential cos is minus sine, and therefore that will be minus 14 cos theta sine theta. So that is what we have here. Dx is equal to 6 sine theta cos theta minus 14 cos theta sine theta whole thing into d theta, which reduces to minus 8 sine theta cos theta d theta. Now x minus 3 we'll find out. So x you have substituted 3 sine square plus 7 cos square. Minus 3 is there. So for sine square, if you take out that 3 common, you will get sine square theta minus 1, which can be replaced as minus cos square theta. And so that will reduce to minus 3 cos square theta plus 7 cos square theta, giving you 4 cos square theta. Similarly, 7 minus x will reduce to 4 sine square theta. Now we'll find out the limits. When x is 3, you are putting x equal to 3 here. That means cos term will not be there. Only sine term should exist. So sine term should become 1. That means theta will be pi by 2. And when x is 7, only cos term should exist. And so that theta will be 0. So limit will vary from 3 to 7 will become pi by 2 to 0. So now I becomes integral pi by 2 to 0 root of, for x minus 3 I will put 4 cos square theta, for 7 minus x I will put 4 sine square theta, so, and then into, for dx we will put it as minus 8 sine theta cos theta d theta. So this root and the squares will cancel out. For the 2 4 I'll have 1 4 into 8, giving you 32, and 1 cos theta here, 1 sin theta here. So here there's a sin and cos, so totally giving you cos square theta into sin square theta d theta, and the negative sign I have interchanged the limits, making it as integral 0 to pi by 2. Now cos square theta into sin square theta, you can replace either cos square or sin square. Here I have replaced cos square theta as 1 minus sin square theta. So it becomes 1 minus sin square theta into sin square theta, which is sin square theta minus sin to the power of 4 theta d theta. Now we will apply reduction formula. So 32 is there outside. For sin square theta, n minus 1 will be 1 by 2. So it will end with a pi by 2. And for 4 minus sin per 4 theta, it will be minus n minus 1 will become 3. So 3 by 4 into 1 by 2 into pi by 2. You just simplify this factor to get an answer as 2 pi. That ends this problem here. We'll see the next problem. I will start with this, evaluate the following. I'm going to apply direct formulas. So I've just taken simple examples here. First one is integral of sine power 5x dx. Second one is integral of cos power 6x dx. Third one will be integral of sine power 7x cos power 3x dx. And the fourth one is integral sine power 4x cos cube x dx. And fifth one is integral minus pi by 2 to plus pi by 2 sine square theta cos square theta d theta. And last one is integral 0 to pi by 2 sine square theta into sine cube theta plus cos cube theta d theta. All these we are going to use direct formulas and apply and show you. So let's take the first problem. I have taken integral sine to the power of 5x dx. Let's call it as I5. We know that from the formula In is equal to, which was integral sine power nx dx, is equal to minus 1 by n sine to the power of n minus 1x cos x plus n minus 1 by n into I n minus 2. Now I5 means I'm going to substitute n as 5 in this formula. So I5 is equal to minus 1 by 5 sine to the power of n minus 1. So 4x cos x plus n minus 1 by n. So 4 by 5 into I n minus 2. So it is going to be I3. Now you apply this formula for I3 again using n is equal to 3 in the same formula here. So I3 will be minus 1 by 3 sine square x cos x plus 2 by 3 I1. Now what will be I1? I1 is going to be integral of sine x dx. You can directly integrate this and your answer is minus cos x. Now use substitution backwards. Put this I1 in I3 and I3 in back here and to get your I5 completely. So now I3 will become minus 1 by 3 sine square x cos square x plus 2 by 3 into I1 is minus cos x. Now you have I5. I5 was minus 1 by 5 sine power 4x cos x plus 4 by 5 I3. So 4 by 5 into I3 is minus 1 by 3 sine square x cos x minus 2 by 3 cos x. So we will just simplify this here. You can take out cos x common for all the three factors and all three of them are negative. So minus cos x, and I have taken this 3 into 5 is 15 here. So I have taken out a 15 as a common factor. Here it is only 5, so I will multiply numerator and denominator by 3. So leaving you as 3 cos sine power 4x, and here it is plus 4 sine square x plus 8 and cos x has been taken out. So this is your final answer. Now the second problem in this case was integral cos to the power of 6x dx. I'll call it as I6 is equal to integral cos to the power of 6x dx. We'll write the formula as usual for cos per n. So In is equal to integral cos to the power n x dx, which is equal to 1 by n cos to the power of n minus 1x sin x plus n minus 1 by n I n minus 2. Now substitute n is equal to 6. So you get I6 is equal to 1 by 6 cos power 5x sin x plus 5 by 6 I4. Now substitute n equal to 4 in the same formula. You get I4 is equal to 1 by 4 cos cube x sin x plus 3 by 4 I2. Now I2 again you substitute n equal to 2 in the original formula. You get half cos x sin x plus half I naught. What is I naught? I naught is going to be integral when n is 0. So integral dx. So that gives you x. Again use back substitution. So I2 will now reduce to half cos x sin x plus x by 2. Substitute I2 in I4. So I4 is 1 by 4 cos cube x sin x plus 3 by 4 into half cos x sin x plus x by 2. Now for I6 you substitute I4. I6 is equal to 1 by 6 cos power 5x sin x plus 5 by 6 into I4, that is 1 by 4 cos cube x sin x plus 3 by 8 cos x sin x plus 3x by 8. So here I have just simplified it. 1 by 6 cos power 5 sin x plus 5 by 24 cos cube x sin x plus you cancel here 3 and 6 to get 2 here. So 5 by 16 cos x sin x plus again here 3 you cancel. So that gives you 5 by 16 into x. And this is your final answer. This is the way you keep applying your formulas. So next we will see, next problem that we had taken was integral of sine to the power of 7x cos to the power of x 3x dx. So here I will consider I m comma n, which is equal to integral of sine power mx cos to the power of n x dx. M and n are positive integers, and we will have the formula for this is I m comma n. We had two formulas, one reduction using cos theta, the other reduction using sin theta. Now we will take the lower one here. 7 and 3 both are odd, so the lower one is 3, so that 3 comes from cos for me, so I'm going to use the formula where cos is being reduced. Cos is being reduced means power n, I m comma n has to be reduced. So I m comma n is equal to 1 by m plus n cos to the power of n minus 1 x sin to the power of m plus 1 x plus n minus 1 by m plus n I m comma n minus 2. Here this is the reduction in cos. Now you just substitute m as 7 and n as 3. So that will give you 1 by 10 cos squared x sin to the power of 8x plus 2 by 10 I7 comma 1. So I7 comma 1, when you substitute in integration, it is integral of sin to the power of 7x cos x dx. You can make a small substitution, sin x is equal to t, that gives cos x dx is dt. So this will become t to the power of 7. When you integrate, it is t power 8 by 8 and t was sin x. So the answer for this is going to be sin to the power of 8x by 8. So I 7 comma 3 will now be 1 by 10. For cos squared I have replaced 1 minus sin square x into sin to the power of 8x plus 2 by 10 into I 7 comma 1 was sin power 8x by 8. So you take up sin power 8 as a common factor, take LCM here and simplify it. So that gives you 5 by 40 sin to the power of 8x minus 1 by 10 sin to the power of 10x, that is equal to, if you can take out sin power 8x as common factor and 2 as the common denominator, in the brackets you will have 1 by 4 minus sin square x by 5. And this is your final answer. Now, depending on the marks, you can reduce, or if they say show that completely in terms of sign, you come to this point. Otherwise, you can leave it at this level. You do not have to change your cos square in terms of sin square. If it is just 3 marks or something, you just directly substitute the formula and leave it in terms of cos square and sin square itself. Thank you. We will see in the next video.